In this lesson, we're going to go over special right triangles. So we're going to start off with an investigate, okay? And we are going to investigate using the squares below. We're going to create right triangles with a diagonal. And what do you notice about the angles in the triangle you have created? All right, so let's look at this first one here. We're going to find the length of each diagonal, and do you notice a pattern with the sides? Okay, so I'm going to start off by drawing a diagonal. All right, so we are going to solve for the diagonal's length using the fact that this is a right triangle, so we can use Pythagorean theorem. Okay, so I'm going to start off with, this is my A, my B, and my C. Okay, so we've got 2 squared plus 2 squared, so my A squared plus B squared is going to be equal to my C squared. So 2 squared gives me 4 plus another 4. And when I add those two together, we're going to get 8. Okay, so my C squared is equal to 8. So I'm going to take the square root of both sides, and we're going to simplify this radical. Okay, so my factors are going to be 4 times 2, and then I'm going to factor that 4 into 2 and 2. Okay, so I've got a pair of 2's with a leftover 2, and so my C here is going to be equal to 2 square root 2. Okay, so that's my answer for this first one. Now let's move into the next one and see if we're starting to notice a pattern happening. Okay, so give me a second. I'm going to create my diagonal. Okay, and so now that I have that diagonal, I'm going to label my A, B, and C. And let's plug into my formula. So we've got 4 squared plus 4 squared is equal to C squared. So 4 squared is going to give me 16 plus 16 equals to C squared. So my C squared is going to be equal to 32. Okay, so I'm going to square root both sides here. And then we're going to simplify this radical. So we can do 2 times 16 for my factors. And then that 16 is a perfect square, so I'm going to have 4 and 4. So that's my pair that I'm going to pull out. And then I'm going to be left over with a 2 underneath. Okay, so my diagonal has a length of 4 root 2. Now let's do it one more time just to make sure we have that same pattern. If you haven't noticed it, I will go over it here in a second. All right, so my diagonal is drawn. We've got A squared, B squared, and C squared that we're going to plug into. So 6 squared plus 6 squared equals to that C squared. And we're going to get 36 plus 36 is equal to C squared. So when I add those together, I'm going to get 72 equal to C squared. And I'm going to square root both sides and then simplify my radical once again. So we'll get here 36 times 2 for my factors. And then that 36 is a perfect square, which will give me 6 and 6. So that's going to be my pair that I'll pull out with that leftover 2. And so my diagonal is going to have a length of 6 root 2. All right, so I know I have 2 questions to answer here. I'm going to start off with the one with the diagonal, the pattern we're noticing. So let me scroll out here for a second. And let's look at all of these together. Okay, So if you notice in every single one of these pictures, okay, we had our side lengths for the squares. In the first picture, it was 2 and 2, 4 and 4 for the middle, 6 and 6 for the last one. And if you notice, every single time we found the diagonal length, our C, it was that number square root 2. So in the first one, we had 2 root 2. In the middle one, we had 4 root 2. In the last one, we had that 6 root 2. Okay, so that's going to help us down below. But the second question that I want to answer here is going to be, what angles were created? Okay, so I'm just going to scroll into this one here. And so keep in mind, remember that this box here, it just means 90 degrees, right? Well, remember, some properties of a square is that your diagonal is going to bisect those angles. Okay, so here we also have a 90-degree angle, and same down here. And so when you take that 90 degrees and you bisect it, you cut it in half, you're going to be left with 45. Okay, so we have 45-degree angles. And so what we're about to talk about is called a 45-45-90 triangle. That's one of our 2 special right triangles. And so this is going to help us determine the pattern that we'll use in those types of triangles. Okay, so let's look down here at the section that's going to go over our 45-45 triangle theorem. All right, so let's look and see what they have. They have in a 45-45-90 triangle, both legs are congruent. And the length of the hypotenuse is root 2 times the length of the leg. Okay, so if you are looking for the hypotenuse, you would take your leg and you would multiply it by root 2. Okay, so let's look over here and kind of label. So remember, in a 45-45-90, you're going to have 2 45-degree angles. They'll probably only give you one, but you could easily know that the other one is also 45. To clarify, we have that this is our leg, and this is our leg as well, and they are congruent. And then you have your hypotenuse that is opposite of your right angle. Okay, so a ratio that I will use with a 45-45-90 is going to be, and you can kind of change up the letter, it's up to you, but I use S because they are congruent, and then S root 2. Okay, so that's a ratio you can use, and you'll see me use it quite a bit on the second page. But now we're going to move into another investigate. Okay, so in this investigate, we are going to use an equilateral triangle below to create right triangles with an altitude. So remember, an altitude is a height. It's going to go from a vertex to the opposite side so that it is perpendicular. What do you notice about the angles of a triangle you have created? Okay, so we are going to find the length of each altitude, and do you notice a pattern with the sides? All right, once again, I'm going to start off by drawing my altitude. Okay, so here's my altitude, and once again, you are going to get a right angle when you have an altitude. And then keep in mind, so I'm going to answer the angle questions with this one, But keep in mind, since this is an equilateral triangle, that all of these angles here are 60 degrees. And when you have an equilateral triangle with the altitude being drawn, it's going to bisect the angle. Okay, so here I'm going to then take 60 and divide it by 2 to get 30. Okay, so these are each going to be 30 degrees here. All right, so now that we've kind of addressed that and what angles you're going to see, you're going to see a 30, 60, and 90 degree angle. Let's see if we can find the altitude for these triangles. Okay, so keep in mind, once again, on an equilateral triangle, okay, because we've got these lovely right triangles being formed here. Let me highlight it. So once again, keep in mind, when you have an altitude on an equilateral triangle, not only does it bisect the vertex, it's going to bisect the side. And so that's going to tell me here that I'm actually going to have a length of 1. I'm going to take that 2 divided by 2 to get 1. And that's what we're going to use in our Pythagorean theorem to solve for my missing side length. So here I've got my, we'll call this my A, my B, and then my C because it's opposite the right angle. So we've got A squared plus B squared, so 1 squared, equals to my C squared, so 2 squared. So we'll get A squared is equal, A squared plus 1 is equal to 4. And then I'm going to subtract that 1 over to get that my A squared is equal to 3. And then we will take the square root. And here we don't need to simplify because it's already simplified since it is a prime number. And we get that my A is the square root of 3. Okay, so now let's look at this middle one and see if we're noticing a pattern. I'm going to draw my altitude. Okay, and so then remember we're going to have that 90 degree angle. And we are going to be bisecting this side here. So I'm going to get that 4 divided by 2 is giving me a length of 2. So we've got my A, my B, and my C. So A squared plus B squared, so 2 squared, is equal to my C squared, which is 4 squared. So A squared plus 4 is going to be equal to 16. Then I'm going to subtract that 4 over to get A squared is equal to 12. And then we're going to take the square root, and this time we do need to simplify. So some factors of 12 are going to be 4 and 3. That 4 is a perfect square, so we are going to get a pair of 2's that we can pull out. And then we'll have that leftover 3 underneath the radical. So my A is 2 root 3. Okay, now let's move into the last one, just to make sure if you've already seen a pattern that we are continuing with that pattern. So I'm going to draw my altitude here. Okay, and so once again, it is going to bisect this side here. So we're going to get that 6 divided by 2 gives me a length of 3. And so we'll use A, B, and C. So A squared plus 3 squared is equal to 6 squared. Then we're going to have A squared plus 9 is equal to 36. Okay, and then when I subtract that 9 over, I'm going to get my a squared is going to be equal to 27. And so we're going to take the square root and then simplify. So some factors of 27 are going to be 9 and 3. And that 9 is a perfect square, so we're going to pull out a pair of 3's. And then we'll have a leftover 3 underneath the radical. All right, so now that we've finished all 3 of those, let's see if there is a pattern happening between them. All right, so if we compare, okay, so in the first one, we had that my a was root 3. In the middle one, we had 2 root 3, and then 3 root 3. Okay, so we notice that they all, with that altitude, are going to have a root 3. But where are they getting the coefficients? Okay, well, let's look and see. Here we had a 1, right? And so my 1 is coming from this side here that was bisected. It is across from my 30. And this one here, I had a 2. My 2 comes from that same length. It's the one that was bisected. It is across as well from my 30 degrees if I had it labeled. And then lastly, we would have that 3 is coming from this bisected side that should be once again across from my 30 degrees if I had it labeled. So that's the pattern that we are going to notice here. Now let's fill it out. All right, so we have our 30, 60, 90 triangle theorem. Okay, so in a 30, 60, 90 triangle, the hypotenuse is twice the length of the shorter leg and the long leg is root 3 times the length of the short leg. Okay, so just writing this out, we have our longer leg is root 3 times my short leg. And then my hypotenuse is 2 times the short leg. Okay, and we'll talk about how we identify that for those of you that might have forgotten. Now let's look over here at this picture and label it. Okay, so let's go ahead and say that this is my 60-degree angle. And we'll say this is my 30 degrees. Okay, so my shorter leg, remember, is going to be opposite of the smaller angle, which is that 30 degrees that we see here. Okay, so this is my short leg. Then my longer leg will be opposite of that 60 degrees. So that's going to be this one here. Because your 2 legs are going to be the ones that are forming that right angle here that we see. Because remember, your hypotenuse is always opposite of that. All right, so like the 45, 45, 90, I do use a ratio, and we're going to use that same letter S. Remember, you can always change it to be your own, that's fine. But I'm going to use S for my short leg. And then remember, my long leg is that short leg times root 3, so I'm going to have S root 3. And then finally, my hypotenuse is 2 times that short leg. Since my short leg is s, I'm going to say this is 2s. All right, so now let's look at some practice problems. We got a few at the bottom of this page, but we'll have quite a bit on the back. Okay, and we're going to find the value of each missing variable. So starting off, I see that I have a 30, 60, 90 degree triangle because of the angle measures given. So I'm going to start by labeling my ratios. We have my s root 3, and then my 2s. Remember, it's all about the angles opposite of those sides. That's how I know. So in this scenario here, it's very nice. They give me that my s is 2. Okay. And so I just then need to plug in that s, that 2, into my other ratios to figure out what is my x, what is my y. Now, for some of these, there's not a lot of work. And so for a lot of it, the work that we require is going to be you labeling your ratios, because that's telling me where you're getting them from. Okay, so for my x here, I have that 2s, which when I plug in my s, I'm going to get 2 times 2, which gives me 4. So x here is going to be equal to 4. Then moving into my y. Okay, so we have that s root 3. So plugging into that, we have 2 for my s root 3. And that's all we need to do because there is no simplifying. So 2 root 3 is going to be my answer for my y. Okay, so that's a pretty easy basic one. Now let's look at number 2. Okay, we're switching into our 45, 45, 90. So we need to label it as such with that ratio. So my 45 is across from that is an s. Then we've got another s over here. And then my hypotenuse is that s root 2. Okay, so with that being said, we already know that my s here is going to be 11 root 2. And I did forget to label these, so real quick, let me just add in that we'll call this one x and we'll call this one y. Okay. So with that being said, if I am solving for my x, right, we have that is an s, and so when we use the s, we know that that's going to be 11 root 2. So x equals 11 root 2. It's just congruent to it. Okay, like I said, you can use your ratios instead of showing all this extra work as part of your work for these types of problems where it's very basic. In this next one here, we do need to show the work because for my y here, we've got s root 2, which plugging into that, we've got that my s is that 11 root 2. And then we need to multiply it by another root 2 because that was a part of what I was given for my s. It is not the root 2 that I need to still multiply it for that ratio. All right, so with that being said, we have root 2 times root 2 just gives me 2. So 11 times 2 is going to give me 22. So my y here is equal to 22. All right, so now let's go ahead and flip it over to the back side where we have some more practice problems that we can work through. All right, so for this one here, we see that 60-degree angle, which means we are going to be dealing with a 30, 60, 90. We know that my missing angle here is going to be 30 degrees. Okay, so I'm going to label my ratios. We've got s, 2s, and then s root 3. Okay, so here we notice that my 2s is what I'm given to be equal to that 12 root 2. So all the other ones for my x and for my y, I do need to know what s is. So I'm going to just take a second and solve by dividing both sides by 2. And then I get that my s is 6 root 2. Okay, so since my y is my s, so for y we know that that is my s, we know that that's going to be that 6 root 2, and therefore y is equal to 6 root 2. Then I'm going to find my x, okay, because my x is that s root 3, I'm going to plug in my s, so my s is 6 root 2 times root 3, and that's going to give me, when I multiply them, remember multiplying the radicals together, we'll just get that 6 and then root 6. 2 times 3 gives me 6. So my x here is going to be equal to 6 root 6. The one thing I do want to kind of mention, for some of you, it won't trick you, but for others it will. Just noticing that since it has that root 2 and it does not mean it is a 45, 45, 90, that can kind of switch up. It is the angles we are looking at to help us determine which ratios we're using, whether it's the 45, 45, 90 or 30, 60, 90. All right, with that being said, let's scroll over to look at number 4. Okay, so in number 4 here, I see 45, 45, 90. So I'm going to label, we've got my s root 2. Okay, so we have a pretty easy one here. We've got that my s is equal to 9. And since my x is got that ratio of s, we can say that that is going to be 9. So pretty easy. Like I said, this is another one where, I'm being extra by showing all of this. Since you're labeling the ratio, it's a matter of just plugging in and you can get your answer. That's fine too, but just make sure you label the ratio. Then for my y here, we have that s root 2. Okay, so plugging in, we'll have that 9 for my s, and then that root 2, which just gives me y is equal to 9 root 2. All right, now let's move on to number 5. Okay, we've got my 30, 60, 90. So my 30 is across from it is an s. My 60 across is going to be s root 3. And then across from my 90, we have a 2s. So in this one here, we know that my s root 3 is going to be equal to 27. Okay, once you label your ratio, you set them equal if that's the length that you know. And then we're going to solve for s. Okay, so I'm going to do that by dividing both sides by root 3. And so this is going to cancel out here. But on the other side, I do have that radical in the denominator, so I need to rationalize. I'm going to multiply by root 3 on top and on bottom. And when we do that, we are going to get 27 root 3 over just a 3. Okay, so we'll get that my s is equal to 27 divided by 3 gives me 9 root 3. Okay, so since my x has that ratio of s, we can say that it is going to be equal to that 9 root 3, and therefore x is equal to 9 root 3. Then moving into my y, okay, my y is that 2s. So plugging into that, we'll have 2 times that 9 root 3, which just gives you y is equal to, we've got 2 times 9 to gives me 18, and then that root 3. Remember, outside numbers multiply to outside numbers, inside to inside. So that's why the 2 is only multiplying to the 9. All right, so moving into number 6. Okay, so for number 6 here, we see that 45, 45, and 90. So we are going to label with our s root 2. Okay, so here, once we find our s, we'll actually have the answer for x and y, since they are the same. But we are going to start off by setting that s root 2 equal to 4 and solving for our s. So I'm going to start off by dividing both sides by that root 2. And we're going to be able to cancel it out here. But on the other side, now that we have the radical in the denominator, I'm going to need to rationalize. So I'm going to multiply to the top and to the bottom that root 2. And so I'm going to get 4 root 2 in the numerator. And then 2 in the denominator, because root 2 times root 2 just gives you 2. So my x and my y both have that ratio of s, which we now know is going to be equal to that 2 root 2 when you divide that 4 by 2. So x is equal to 2 root 2, and y is equal to 2 root 2. Okay, now let's look at number 7. So in number 7 here, we see that 45, so we know we have a 45, 45, and 90. If you want to label that missing angle, we can. And so we're going to label our s root 2. So once again, this is another one where we know my s root 2 is going to be equal to that square root of 10. And once we find our s, we will then have both answers. Okay, so I'm going to start by dividing by that root 2. Okay, now this is another one where you can rationalize it, or what I'm going to do is I'm going to break it apart. I've got that root 10, which could be changed into root 5 times root 2 over that square root of 2. And so I'm able to cancel out that square root of 2 on both sides actually now. And I'll be left with my s is equal to the square root of 5. And since x and y are going to be my s, we know that it's going to be that square root of 5. So x equals the square root of 5, and y is equal to the square root of 5. Okay, moving into number 8 here, we have that 30-degree angle. So we are going to be dealing with a 30, 60, and 90 triangle. And so I can label my sides as s root 3, and 2s. Okay, so in this one, we do know that my s is now going to be equal to that 5 root 3. And so since my x here is going to be s root 3, we are going to get that 5 root 3, my s, times another root 3. Okay, and so we are going to get 5 times that root 3 times root 3 gives me 3, which will give me 15. Okay, so x is equal to 15. Then for y, we have my y is that 2s. So we are going to take 2 times that 5 root 3. And we are going to get 10 root 3. Okay, once again, outside numbers only multiply to the outside. Okay, moving into number 9. We have 30, 60, 90. So labeling, we've got our s is my x. My 6 is to my 2s, and then s root 3 is my y. So here I know my 2s is equal to 6. Therefore, s, using that division, is going to be equal to 3. Okay, so since x is my s, we know that that's going to be that 3. X is equal to 3. Okay, then for my y here, we have that that's my s root 3 ratio. So when I plug in, I get 3 root 3. And so y is equal to 3 root 3. Okay, moving into number 10, we have 45, 45, 90. So that's going to give us an s root 3. This is another one I did forget to label. So I'm going to call this side x here, and we'll call this one y. So since, oh, I forgot to label this as s root 2. Sorry, my bad. We've got, since my s is going to be equal to that 27 root 3, and my x is s, okay, we know that x is going to be that 27 root 3. Okay, and then for my y here, I'm going to take my s and we're going to multiply it by that root 2. So we'll get that 27 root 3 times root 2. And so then my y is going to be equal to 27. And we'll multiply our inside times our inside. So 3 times 2 gives me 6. So 27 root 6. Now let's move into our last two problems. We got number 11. All right, and number 11 can be a little tricky. So what I'm going to do, since we do have the two triangles, is I'm going to start by looking at the triangle that I know a side length for, and that's going to be my 30, 60, 90. Okay, remember this is going to be that 30 degrees, or sorry, that 60 degrees up top. Okay, so I'm going to have s, 2s, and then my s root 3 over here. Okay, and I'm doing this in different colors for some of you. You might want to do this labeling with different variables, and I'll kind of show you that as well. But here, I know that my s is equal to 9. Okay, so when I'm looking for that z is my 2s. Okay, so I'm going to take 2 times that 9, and we get 18. Okay, so z is going to be equal to 18. Now, it is also very helpful, even though it's not a variable labeled, for us to find our s root 3 because of the fact that we are going to be using that side length as the only side that we'll know in the 45, 45, 90. Okay, so I do need to figure that one out as well. So we've got my s root 3 is going to be equal to, we've got 9 root 3. Okay, so what I'm going to do is I'm going to switch colors because now I'm going to move into, I now know and I'm finding lengths for my 45, 45, 90. In case you hadn't noticed, I did all of those in this pink color. But what could be helpful for some of you, if you're not using the colors, is to maybe switch the variable and not use s in this one, okay? So in this one here, we can use, I don't know, we'll call it a, okay? So in a 45, 45, 90, this would be my a, and then this one would be my a root 2, okay? So with that being said, I would then set those two equal to each other. We would have my a root 2 is equal to 9 root 3. And I'm going to divide by that root 2 to solve for my a. Okay, so I'm able to cancel it out here. And then on this side, we're going to rationalize. We're going to multiply by that root 2 on top and on bottom. So in my numerator here, I'm going to get 9 root 6. And then in my denominator, that root 2 times root 2 just gives me 2. So I can leave this as 9 root 6 divided by 2, or if you want to, you can change that into 4.5 root 6, but I'm going to leave it as the fraction. Okay, and since my x and my y are both that a ratio, and we know that to be that 9 root 6 divided by 2, I know that x is 9 root 6 divided by 2, and so isn't my y. Okay, so with these types of problems, color coding could be helpful, but also just changing the variable in which you're using the ratio for could also help you so that you know that it's not that same s root 3 down below in the 45, 45, 90. All right, let's move into our very last problem, another semi-challenging one. And I notice here that once again, it is the 30, 60, 90 triangle that I know a length for. So I'm going to start by solving in this bottom triangle here with my 30, 60, 90. So this right here is going to be my s root 3. We have my s and then my 2s. Okay, so we've got that my s root 3 is going to be equal to 18. I'm going to divide by that root 3. Okay, and so it's going to cancel out here. And on the other side, I will need to rationalize. Okay, and when we do that, we'll get 18 root 3 over 3. Okay, so that 18 is divisible by 3, and so we're going to get that my s here is equal to 6 root 3. And so that's going to help me find my z. Okay, so z here, remember that's your s, which we said was 6 root 3. So z is just equal to 6 root 3. All right. Now we do need to find that 2s because once again, if we look at the 45, 45, 90 triangle, okay, I know none of the side lengths, And I'm going to use a different variable here. Actually, we'll stick with an a. And then my a root 2. Noticing that I know no side lengths in those triangles or in that triangle. And so, therefore, I need to use the reflexive side there, that shared side, which means I need to know that side length. So, I'm going to go back over here and I'm going to solve for my 2s. Okay, and that's going to be 2 times my 6 root 3, which will just give me 12 root 3. And so right here we know that this is going to be equal to my 12 root 3. Now my x and my y are both going to be that a ratio. Okay, so I'm going to need to find a. Well, we've got currently that a root 2 is equal to that 12 root 3. Okay, so I'm going to divide both sides by that root 2. And I'm able to cancel out on this side. And on the other side, I do have to rationalize. Okay, so then we'll get that my a is equal to, we'll have 12 root 6 divided by 2, which we know is going to give me that 6 root 6. All right, so since x and y have that ratio of a, and we know that that is my 6 root 6, we know that x is going to be equal to 6 root 6, and y will be equal to 6 root 6 as well. All right, that is it for our lesson over special right triangles. We got the 30, 60, 90, and 45, 45, 90.